And we're going to look at conditional statements. Before we get into that, I just want to make sure that we're familiar with a few of the ways to look at relationships. And when we're making our statements, we're evaluating whether they're true or false, and we want to have the tools to kind of create relationships between numbers or values. So some of these are probably pretty straightforward, but just want to make sure you understand greater than, less than, greater than or equal to. When we are checking if something is equal to something else, we're going to use two equal signs, not just one. When we use just one, that's setting the value to something. The exclamation mark equals is the same as not equal to. And when we look at logical operators, sometimes we're looking at maybe more than one statement, and so these are helpful in allowing us to evaluate those statements or create more complex conditions. The most common expression that we'll see is the if statement. In this case, we've done this before, but just to review, you'll write if, and then you'll write the expression that you want to evaluate, whether it's true or false. And then inside the code block, inside the braces, you'll have some code that will run only if that expression is true. You might also have, you don't have to have, an else statement, which will run if that expression is false. So that allows us to kind of have two possible scenarios, and we can kind of switch between them. So here's a quick example of using if and else statements. I've already started this sketch. It's got a size of 800 by 800 pixels, and we started the void draw. We're going to be redrawing a white background so that you can see changes from frame to frame. Let's create an if statement. We'll say if mouse x is less than width divided by 2. So this is saying if it's on the left-hand side of the sketch, and we're going to execute this code block inside of here. Well, let's say we'll draw a rectangle. It's going to start from 0, 0 up in the left-hand corner. The width will be width divided by 2, and the height will be height. I also want to put a fill on this, so let me, for right now, just turn it red. So this is saying if the mouse x is on the left-hand side, less than the width 2 divided by 2, draw a red rectangle. So let's see if that works. We'll do Command R to run it, and here is our sketch, and you can see that as I go to the left-hand side of my mouse, it's changing there. We haven't written the else statement yet, so let's write that right now. So if this statement up here is not true, then I'll execute this code block. Let's use a green fill, and what we'll do is make a new rectangle. If we want it to be on the right-hand side, so we're trying to just kind of divide the sketch in half. We'll start at width divided by 2, 0 for the y. Again, width divided by 2, and height for the length and the width. Semicolon at the end, and let's run that. And you should see we have an if statement, if else statement. You might also use else if statements, which they start off like the if and else statements. You have that first Boolean expression, and it executes the code in this block, and then it'll go to the next one, and now this one will only go if the code in the previous expression is false and the current Boolean expression is true. So this lets us create a bunch of different scenarios, and you might have a lot of these, and at the end you might end with an else statement, or you might not. It's all about kind of creating the conditions and the behaviors that you want. Okay, so let's try to rewrite our sketch to incorporate else if statements. So in this case, if else works when you have only two possible scenarios, but now we have three scenarios. Now what I want to do is divide the width of this sketch into 3 and have 3 different sections where I can hover over and change the color. So I'm going to change this to width divided by 3, and I'm going to also change this to width divided by 3 so that rectangle only happens on a third of the sketch. I deleted the other one just to simplify it. Let's just make sure we're getting what we intend. So this is the first part, and then we want to have a center section and then a right section. So we want to create a scenario where this statement has to be false, and we're creating a new situation on top of that. So we're going to write else if. The new situation is if mouse x is less than width divided by 3 times 2, so it's 2/3 of the sketch. Because it's else if, it's excluding this statement or this circumstance up here. So we don't need to worry about it kind of taking over. Let's do a blue fill here, 55, and now we're going to change it from the width divided by 3 to 0, width divided by 3, and height. So the starting x, the starting y, the width of it, and the height of this rectangle here. Let's see if that part is working for us. And you see what we have, these two scenarios, and now we got to get that third one in there. So since it's the last one, we don't need to write an else if statement. We can just write else. So generally you'll do else ifs to kind of hit the scenarios in the middle, and then you can wrap it up with an else. So it just makes it a little bit easier. Let's go to 255 here for the green value. We'll start it at width divided by 3 times 2 now, 0, and width divided by 3, and height. So the same width and height for all of these things. We're just kind of changing where it starts in the x. And let's make sure that we've got 1, 2, and 3. So we've created these 3 conditions. I just wanted to show a quick example of connecting multiple Boolean tests together. We talked about this at the beginning of the video. We can use these operators such as and when we want to do multiple conditions. And so this would be doing the kind of mouse hover test that we did in the previous sketch, but now we'll have 4 quadrants. And in order to get 1 quadrant, we need to test that the mouse x is on the left side or less than width divided by 2, and also mouse y, in this case, the white square, needs to be less than height divided by 2. So those 2 conditions have to be true. And then in this one, it's the mouse x is the same, but the mouse y is going to be greater than height divided by 2. So this is just an example of what that looks like and how you can create multiple conditions in here. We're using and between these 2 Boolean tests. Okay, so the next thing we're going to look at are loops. A lot of times, I think one of the goals in programming is to kind of deal more efficiently with repetitive processes, and loops really allow us to do that. We'll look at 2 types of loops here. One of them is a while loop, which is pretty simple. It works kind of like the if statement. So while a certain condition is true, then we have a Boolean test here, a true or false statement. It'll execute the code in the code block, and every time it runs through this, it will kind of check if the Boolean condition is still true, and if it's still true, it'll keep running. If the condition is false, then it's going to stop. So here's an example of that. In this case, we created a variable called x. It's going to be the x position, and this would basically draw a series of squares or rectangles across the screen, but it only happens while x is less than the width of the sketch. So we have that rectangle, and we're incrementing x. We're saying take x and add 20 to it. So you'll see that it'll draw the rectangle, then it'll add it'll increment the x, and then it will check again if that condition is true, and it'll only go until the condition, it'll only go for as long as the condition is true. So here is what that code would look like in processing. We set the variable up here, x equals 0, and we have the while loop. We're evaluating that condition, x is less than width, and we're iterating over here. And once this finishes, it's going to evaluate this expression again, and this should produce a series of squares or rectangles going across the screen. Another loop that we're going to look at is called a for loop. So what's nice about a for loop is it lets us, it's kind of a compact way of using a variable like we did in that while loop, setting the Boolean test, and then iterating the expression kind of within the first line. So that's all going to go at the top. You have 3 different sections that are separated by semicolons. You have the code block still, so it's going to execute the code. It's going to iterate the expression based on what was written in the for statement at the top. And then it will, again, test the Boolean expression to see if the loop should continue. So on the first line, for, and inside of here, you'll see the three elements that we're going to write. One is the initialization. So we are going to declare and initialize a variable. In this case, we'll call it I, int. It's a type int, I equals 0. We set the Boolean test as long as I is less than 5. And then we have the increment I plus plus is the same as saying add 1 to I. So in this case, it would execute the code that's in there. It's going to add or iterate the expression. I already said it's adding 1 to I, and it will test the Boolean expression. In this case, is asking, is I less than 5? So this loop would run 5 times. The value of I will be 0, 1, 2, 3, 4. And then once it iterates and adds up to 5, that's no longer less than 5, so the expression would stop. One thing I like about this is that to me it's self-contained, and also when we look at variable scope, we can use I in this case, and I will only apply to what's inside of the curly braces, and so this is local variable scope. And what's nice about this is that you could use the variable I in another for loop, and you wouldn't have problems with the variables kind of duplicating or kind of causing fusion, because it's kind of self-contained within this. So that makes it a powerful tool. Sometimes, I like using I a lot, and I'll just be using it many times in the code, and that's helpful for me. Okay, so let's use what we know about conditionals, loops, and randomness to create a pattern. We're first going to start by setting the size of our sketch. In this case, I'm going to make it a little bit wider than tall. I'm also going to change the frame rate at this point to something lower so that I can see this pattern changing over time. If I leave it at the default frame rate, it's going to go really fast. I'm going to start with the background here, but I'm going to need to redraw it as I go along. Inside the draw, we're going to start with using a for loop. I also, probably at this point, I might want to use some variables to start with. I'm going to put these at the top so they're global variables. Maybe we have x and y values that we'll set at 0, but they'll be incremented. And let's set a sizer at 20. Okay, so we're going to start by just trying to draw a row of shapes across horizontally. We're going to use a for loop in this case. I'm going to start with, again, I'm going to use I for my variable, initialize it here. I'm going to say as long as I is less than width, using semicolons in between all 3 of these elements, I plus equals sizer. And from here, let me just make sure it's working. I'm going to say x plus I, because I want to add this new incremented variable. That's where the rectangle starts. I'm going to say, for right now, I'll just say 0. So it's going to be at the top. And then I'll say sizer and sizer. And let's just run that to make sure we're off in the right area. Okay, so we have this first row of rectangles. That's good. Now, if I want to create a pattern, like a gridded pattern, what I want to do is have nested for loops inside of each other, or nested loops. You could also do this with while loop, but I'm going to write this inside of here. So I want to be very careful that these curly braces are going to close afterwards. So this can trip up a lot of people if they forget to close them. I'm going to make another variable here. Now I don't want to use I again because I'm still within this larger code block and that would create redundancies and issues. So I'm going to make a new variable called j. And let's say as long as j is less than height, it's pretty similar, j plus equals sizer. This is going to give me a gridded pattern. And also, so you see I need to close these inside of here. This one is closing out this first for loop, but I need to make sure that it closes here. And I like to hit format or command T to just show me how these are nested inside of each other. You can always see if these are closed out by clicking in here. Okay, so this should give me, I have to make one adjustment. I want to say y plus j now so that the y value, start value, gets updated. Let's take a look at that. And there we go. We have a grid of rectangles or squares. Let's keep layering different things on this to make it more interesting. What I actually want to do is start to play with randomness here. Inside of the second for loop, I'm going to make a new variable, and I will declare it up at the top just so it's there. You know, actually, if I don't put a value into it, it's going to put a default value, which I think is probably going to be 0. But maybe we'll just you know, we can set this to 0.0. It could be anything. I mean, actually, I'll just leave it blank to kind of write less code. Okay, so what we want to do is this variable has been declared up here, and we want to set a new value to it, and then we want to evaluate it. So we're going to say r is equal to random. I'm going to say random2. This is going to return a value in between 0 and 2. And so what I'm going to do is use this and an if statement to kind of create different conditions or scenarios. I'm going to say if r is less than 1. Now, if it is picking numbers randomly, probably about 50% of the time it's going to be less than 1. We can think about it in that way. If that's the case, then let's draw a rectangle here. And maybe we'll say else. So this is, again, if r is not less than 1, if it's greater than or equal to 1, we want to, maybe we'll draw an ellipse here. Now, I need to offset the value just a tiny bit. What I want to do is do x, because remember, ellipses start from the very center point when we draw them. So we need to make a slight adjustment, a slight shift. We're going to say add sizer divided by 2. So that's going to just shift it over so that we're putting these shapes in the same location. And then for y, we're going to do the same thing, y plus j plus sizer divided by 2. We'll use sizer and sizer. And okay, let's just see how that's working out. Okay, so I am not drawing a background into draw, so we're getting a little bit of ghosting. So let's just turn that on. Yeah, and so I changed the frame rate earlier, right, to be a little bit slower, and you're seeing that we're using randomness to kind of control how this pattern gets set up, and we're probably about 50% squares and about 50% circles. And if we change the values, like for example, if I said if r is less than 0.1, now you should see that it's going to be mostly circles in this case and fewer rectangles, because this situation happens less frequently. Yeah, and you see it's mostly circles, but a few rectangles when this condition is met. So I'm going to turn that off. I'm going to try doing a few things. Like at this point, maybe we want to start. We could start changing colors in here. I mean, you could put in your own random colors, and anything that's inside this code block will only pertain to this to this section. So I could change the color here, and I could change color again here, and you can kind of create these different these really nice scenarios. I'm gonna start with you know, one thing that I could do is kind of create a gradient-like effect by using maybe the x position. Now the x position goes from 0 to 960 in this case. So 960 is actually is higher than the color value that could be contained. It only goes up to 255. So I'm going to go a little bit above it. What I'm doing here is I'm actually using the x value and then using the y value here. I'm gonna put that in like that and use that to kind of color it. There is a function here that could keep this within a certain range. It's called constrain. So because this value is going to actually get above 255, I mean, if it ever gets above it, it's probably fine. It just means that you can't really register that difference, but constraining it will limit it. There's another way to remap functions, which we'll get into later. So just so you're aware of what that means. If we want to, let's say maybe we only want these to be white, you could do this, and this would now all your circles are white and everything else. You can see that using this, there's a gradient kind of going both in the x and the y direction. That's the point of doing that there. Just for the sake of maybe making it a little bit easier, I'm going to take this out and put it up here so that now hopefully you can see that it's going to this fill is going to affect both of these shapes. If we do that, then you should see that the shapes have that kind of gradient fill color going across, but they still are different shapes here. If we wanted to add a third scenario, maybe we'll make a third scenario here. So we'll do squares, circles, and maybe just to make it easy, we'll do like a smaller rectangle. That would be pretty easy. So if we're going to do something like that, we're going to need an else-if statement here. We need a new condition here because we have at least 3 different scenarios. So I'm going to say else if r is less than 2. So we're going to try to evenly distribute this again. And then down here, we'll write this if statement. And I just want to make sure this closes. Okay, so here I'm going to just do, let's say, x plus I, y plus j. And maybe I want this to be like a skinnier rectangle. So let's see what that looks like. It's only going to be half the height of the other rectangle, and we should see, yep, that one is making a smaller rectangle. So this is a way to use else if statements to create that. So this is a cleaned up version of the sketch that I just worked on. It only has squares and circles, but I added one more thing that I wanted to go over. We've gone over how to save frames as still images, JPEGs, TIFFs. There is a way to save PDFs, which are really nice because they're vector files and you can import them into Illustrator. I wanted to go over that process briefly. And there will be sample code of this, so you can take a look at this. If you want to find out more about this, there are some examples, code examples here at the processing.org website. We have to use a library in this case, and we'll use more libraries as we go on. But the way to import a library is by putting that at the top. This is even above the setup. If you go to the top of your processing screen, if you go into Sketch and import library, you can usually import your library from there. And we're gonna, you could actually just get it by hitting the import PDF export. Oops, so that brought it up at the top. But I already have that, so let me just show where that is again. It's right here. And we need to make a variable using a Boolean, and we're gonna call it record. Again, a Boolean can only hold a true or false value. In this case, the Boolean is here, and I believe it, since we haven't set it, it will have false, or it won't be turned on at this point. Okay, so what we want to happen is we'll use another if statement. If that Boolean record is true, then we'll start this function, or we'll call this function begin record. You say what type of file you need, and then you put the frame, or you put the file name here. We're going to use frame numbers again, so this is a way for us to do that. And you want to put this at the top of everything that you want to start recording. So if you put this at the very bottom, then it might not be on. Basically, once it's on, it's going to record everything that's from here. And at the very end of this, we need to set another conditional because we don't want this to keep recording and recording and recording. We want this to be a one-time thing. Once the recorder's on, it records that one frame and then it shuts itself off. So we're going to say if that record or if the record is equal to true, we will end the end record, and then we'll send, we'll change the variable, the Boolean record, into to false. Again, when we're changing the value of something, we'll use equals, and when we want to look and see if something is equivalent, we'll use equal equals. We're not doing in this case. We have one block of code down here. It's using this this function mouse press, which is basically when you press the mouse. And this is the function here, or the bit of code that's going to turn that record Boolean on and off. So if I run this sketch and I press the button, that should record a PDF. Okay, so this is my folder, and you can see this is the sketch that I just saved. That comes in as a PDF. The PDF should save into the sketch folder. So make sure you save your sketch before you do any of this.